Homework 1, problem 3. Prove that the two-dimensional rotation matrix preserves dot products. And so here we're going to have two vectors. Our vectors are general vectors. A vector is AX, AY. These are two-dimensional vectors. B vector is BX, BY. Upon rotation, our components for both systems, for A and B, give us that AX prime is equal to AX cosine theta plus AY sine theta. AY prime is minus AX sine theta plus AY cosine theta. And identical for the B vector, we have that BX prime is BX cosine theta plus BY sine theta, and BY prime is minus BX sine theta plus BY cosine theta. That is just the definition of how the rotation acts on these two-dimensional vectors. To prove the equivalence of the dot product, what we're going to want to do is figure out what A dot B is in both the primed and unprimed components. We're going to start with the primed components because we have the substitution rules for those. And so this is AX prime, BX prime plus AY prime, BY prime. First, I'm going to look at simply the product of the X components, simply to simplify things a bit. This single term is going to give AX cosine, AY sine, BX cosine, BY sine. Now, whenever I multiply these two together, I'm going to get a few terms. I just do the FOIL. So first, AX BX cosine squared. And then I'm going to do last. And so AY BY sine squared. And then I have the mixing terms. And so I'm going to get a AX BY cosine sine and AY BX cosine sine. Continuing with the next term, I'm going to get this minus AX sine theta plus AY cosine theta. BX minus BX sine theta plus BY cosine theta. Then when I do the FOIL on these two, I'm going to get, again, an AX BX, but this time two minuses make a plus, and I get a sine squared. The final terms, ay by cosine squared. And then, using a little bit of foreknowledge this time, I'm going to get a minus ax by minus ay bx cosine sine. When I sum these together, I see I'm going to use this identity that cosine squared theta plus sine squared theta is equal to 1. And here I'm going to get a minus ax by cosine sine. Here I get a positive ax by cosine sine. Those are going to cancel out. So those cancel with those. I'm left over in the end, of course, with the simple statement that this is going to be equal to ax bx plus ay by. And therefore, at this point, we have shown the equivalence that ax prime bx prime plus ay prime by prime is the same as ax bx ay by.